The Bluetooth device is ready to pair.
Hello guys, hello everybody, hello world, hello Philippines, hello other parts of the world. Shout out to uh, Mr. Sigmund Adora, shout out to Mr. Titi Delantes, shout out to Ma'am Dalia Bautista, shout out to all of you guys. Nice chatting with you with our group chat. Okay, going back to business. Okay, we have the Hess Law discussion. Hess Law discussion is talking about the heat selection of the chemical reaction or the enthalpy change of the overall reaction. So this is a problem regarding chemical reactions, obtaining the value of the enthalpy change of the reaction, okay, the overall reaction, okay. So before going into the discussion for this one, so I need to emphasize that this is very important theory to be used in the second law of thermodynamics. Okay, second law of thermodynamics, which is the Gibbs free energy is equals to the enthalpy change delta H minus the temperature times the delta change in enthalpy. Okay, and also it can be stated differently in another formula also, which is equal to the Gibbs free energy of delta G is equal to the change in internet energy minus temperature times the delta change in enthalpy. So it's also related. Actually, my flag in this month is all about thermodynamics, but it touched a little bit of physical chemistry due to the fact that most of the enthalpy and the entropy topics are being discussed in physical chemistry also. Okay, so like this. So before going to this, I may define what is really a Hess law. HESSLAW. There's a lot of laws in science, right, as you can remember, and in chemical engineering. Okay, but this time, specifically the Hess law. Okay, the Hess law states that the sum of enthalpy changes of each reaction step is equal to the enthalpy changes of the overall reaction. Okay, so enthalpy change in the overall reaction is equal to the enthalpy changes of formation of the products minus, okay, the delta change of enthalpy formation of the reactants. Okay, then both enthalpy of reactant and product must be multiplied with the number of moles. Like that, because it's usually given in kilojoules per mole shot according to the values of standard heat of formation or standard heat of enthalpy. Okay, something like that, guys. And then there's the standard heat of formation, the standard heat of formation of various elements, and the standard temperature and pressure. When you mean standard temperature, it should be referring to 25 degrees Celsius to 90 Kelvin here, okay? And the pressure here is 1 atmosphere. So I have here, I printed the values of enthalpy, change of formation, or standard enthalpy of formation of various organic and inorganic liquids, something like that. I'll show you. See? Standard, this one. Standard enthalpy of formation of or thermochemical properties of substances, inorganic substances. Here. So a lot. Okay, sometimes if the enthalpy of formation or standard enthalpy of formation is not yet given, okay, in the chemical reaction such like this, okay, okay, then we need to use this one, especially if the temperature is not mentioned, that means standard, which is 25 degrees Celsius, then 20 Kelvin at 1 atmosphere. Okay? Something like that. Okay. Now, before touching this problem, chemical reactions, we need to find the overall reaction of the enthalpy change of the reaction. This one. Okay? So I need to show to you a basic chemical reaction so that we can understand a little bit, okay, something like that. Okay guys, if we have a reaction of A plus B, first reaction step, okay, we have A plus B is equals to C, ganon. And then the enthalpy change, for example, only is, let us say, 10 joules, something like that, okay? Since I'm not stating the temperature, so this is automatically at 298 Kelvin and 1 atmosphere pressure, standard pressure. Okay? And then another reaction step, C plus D is equals to E. Like this. Second reaction step, C plus B is equals to E. So our overall reaction will be, okay, A plus B plus C plus D is equal to C plus E. Ganon. So you will add all the reactants first from first reaction step and second reaction step, and then add also after that the products, something like that. So you need to identify what will be cancelled throughout the reaction steps. So in here we cancel C because it is equal. So C. So what will remain will be the overall reaction A plus B plus D is equals to A. So this is our overall reaction. Since if we have, for example, if we have delta H in the second reaction step, which is equal to 20 joules, so our enthalpy change of the reaction is equals to the first enthalpy in the first reaction step plus the enthalpy on the second reaction step. So that is our delta H reaction. Enthalpy change of the reaction is equals to change in enthalpy 1 reaction step, first reaction step, plus change of enthalpy in second reaction step. So we have to add the enthalpy, so 10 plus 20 is equals to 30, something like that. Okay? So that is 30 joules, like that. This is the enthalpy change of the reaction. Simply adding that one. Then if the situation needs to reverse that one, we need to reverse so that it could become stable and we can cancel the elements, the compounds, because our purpose really is to simplify the chemical reactions. We are really loving if our chemical reactions will be reduced and simplified to its reduced form. That's why we need to cancel elements or compounds that have the same number of moles to reduce the complexity of the chemical reactions during stabilization and then the equilibrium process also, something like that. Okay, that's really our purpose. Then if we reverse that one, for example, this one, in the second reaction step, which is C plus D is equals to E. So if you reverse that one, that could be E is equals to C plus D. And then your delta H for that change in enthalpy also for the second reaction step will be now negative 20. Okay? So the rule, if you reverse, change the sign. Okay, if you multiply that with a figure in order to balance the first reaction step and second reaction step, just to cancel really, okay, the similar quantities of its elements and compounds, then you also multiply the change of enthalpy of the reaction 1 and reaction 2, or the first reaction step and second reaction step. Okay, like that. And then add that up, and that will be your change of enthalpy of the reaction. Ganon. Okay, now let's go back to the problem here. This one. Okay. 2 moles of ammonia gas is equals to nitrogen gas plus 3 moles of hydrogen gas. So meaning to say the first reaction step or the first reaction is a decomposition reaction. So we don't need to identify whether this is a reversible or reversible chemical reaction. That is not our concern here, because we are not talking about entropy and gives free energy. We are not concerned with the spontaneity, how spontaneous the chemical reaction really is. Our concern here is to obtain the change of enthalpy or the heat content of this chemical reaction. Okay? Now, the second chemical reaction, 2 moles of water is equals to 2 moles of hydrogen gas plus oxygen gas. Okay? And then third chemical reaction, nitrogen gas plus oxygen gas is equals to 2 moles of nitrous oxide. Now, each reaction has its own change in enthalpy. Okay? The first reaction at the top is positive 92 joules. The second reaction is 572 joules. The third reaction is negative 180 joules. Now, the question really is, what is the overall chemical reaction? And what is the change in enthalpy of the reaction? Ganon. Okay, so we need a blank sheet of paper, and I show you how to solve this one. Diba? Okay. Guys, the first step to obtain or to do is to balance the chemical reaction. In the first reaction, it is balanced or not. Then you have to verify first the balancing of the number of atoms as per the law of conservation of mass. Or specifically, the law of conservation of matter in chemistry. That the number of atoms in the reactant should always be equal to the number of atoms in the product in equilibrium stage. Something like that. Okay? So, 2 moles of nitrogen, investigate only visualization, it will do because it's just already, simple because we already discussed it a while ago, okay, in my previous class also in chemistry. Okay, 2 moles of nitrogen, bonus, 2 moles of nitrogen in the left, and 2 atoms of nitrogen in the right, balance shot, 2 atoms, okay. Hydrogen, 6 atoms, balance shot, 6 atoms, balance shot. And then second reaction for hydrogen, balance, oxygen, 2 balance shot. Third reaction, 2 atoms of nitrogen and oxygen, balance. Okay, balance both. Now we are very, very lucky this time that the chemical reaction presented in the question is really balanced at all. Okay, because sometimes the questioner is giving the unbalanced chemical reaction. That's why we need to do the balancing of the chemical reaction first before anything else. But this time, this is balanced already and we don't have to worry about that. Okay, the second step, we need to obtain the commonalities, the common of each reaction. Okay, so that we can simplify and reduce the overall chemical reaction as much as we could. For example, taking chemical reaction 1 and reaction 2, what is common for this? Okay, common elements or common compounds upon visualization. Okay? Okay. So, guys, the common and the chemical reaction 1 is, and 2, reaction 1, reaction 2 is the hydrogen gas. Okay, we have ammonia, we have nitrogen gas, we have the oxygen gas, and we have water. So they have different elements and compounds involved, except for hydrogen gas, which is the same in chemical reaction 1 and chemical reaction 2. So all we have to do is to cancel this out as the first rule. Or second rule pala, because the first one is to balance the chemical equation. Okay, the second rule. Now, you cannot cancel this because this hydrogen gas are in the products. Okay? You cannot cancel if you add this because this hydrogen gas are in the product side. All you have to do is to reverse the chemical reaction. Could either be the chemical reaction 1 or the chemical reaction 2. Something like that. Okay? You get the point? Okay. But as a rule of thumb, you will be able to reverse the second reaction most of the times. Okay? The second reaction, not the first reaction. Especially when the second reaction has the least or the less number of moles. For example, in second reaction, there is only 2 moles of hydrogen gas. And in the first chemical reaction, we have 3 moles of hydrogen gas. So that's one identification that you have to reverse the second chemical reaction. And the second rule also is that it is always the second chemical reaction to be reversed. Something like that, okay? You get the point? Things like that. Now, the third rule for this chemical reaction and chemical reaction 2, you need to multiply that with the number of moles, whole number, or could it be fraction also if you want, but the least fractional form first. Start with the least fractional form first, starting with 1/2, 1/3, 1/4, like that, followed by 2/3, 2/4. Okay, it depends on you. Okay, why we need to multiply both sides of the number of atoms? Because just to cancel out. So in this case, chemical reaction 1, we need to multiply this by 2 equals to 6 atoms of hydrogen. And in the second chemical reaction, we need to multiply the hydrogen gas with 3. Okay, now if we multiply hydrogen gas, we need also to multiply the other quantities. And chemical reaction 1, chemical reaction 2. Okay? Like that. So I will now show you. Okay, so this is gonna be like this. So 2NH3. So this will be also the process in complex chemical reaction. This is only the basic one, but if you are given a complex, you have to follow the same rule. Okay, and then sometimes you also memorize the prediction of the products is very important here. The prediction of the products, especially it's discussed in chemistry, so you should inject that in your brain cells. The rules of chemical reactions, right? The 5 types of chemical reactions is very important here, really. And then the balancing of chemical equation also, the balancing of chemical reaction. So this is a series of reaction step talaga siya before obtaining the overall chemical reaction. Okay, like that. Okay, now 2 moles of ammonia. And then guys, if you multiply the reaction, each reaction with a certain number, you also multiply the enthalpy values. Okay, don't forget that. Because if the question was, what is the overall enthalpy change of this reaction? And then you will become wrong if you will not multiply that also with a figure. But if you reverse that, reverse also positive, negative, positive, and add that all the time. Heat summation lang good siya, guys. Okay? Heat content summation, meaning you have to add. Okay? Like that. Sometimes it will just become a minus if the second enthalpy change is negative. Okay, so positive enthalpy change plus negative, so it will become positive minus negative ratio. But it doesn't mean you have to subtract that one. Okay, it's still additional, but it's all only in the sign. Okay, that's going on. Going on the sign, then you have to take, as I told you, physical chemistry and thermodynamics are concerned with the direction and the signs of the energies. Okay, a lot of energies, right? As I mentioned a while ago. Okay, so you have to take that one also. Okay, now 2NH3 ammonia. Okay, my gosh, is equals to N2 plus 3H2. Now, guys, you have to multiply this by 2. Okay, like that. If you multiply this by 2, guys, then you have to multiply the enthalpy, which is 92 by 2 also. So how much? 92 times 2. That is 94 na siya. 94 joules. Ganon. Okay? 94 joules. Okay. Now, 2 moles of water equals to 2H2 plus oxygen gas. Now multiply this with 3 so that the hydrogen gas will cancel. Like this. In the second reaction I presented a while ago. So if you multiply by 3, the 572 joules also enthalpy change of this reaction multiplied by 3. So 572 times 3, ito na lang nato ha. Okay. So 17, 16. J. Okay. So we have now 2 moles of ammonia or 2 atoms of moles. Sorry, moles siya. Basta coefficient, guys, mole siya ha. But totality atoms if you include the subscript. Okay, as I told you a while ago over and over again. Subscript times the coefficient is the number of atoms. Number of moles, figure or number beside the compound or the atom or the element, that is mole. Since there's no subscript at all, so that atom will be equal to mole. When you speak during your discussion, you have to be careful also. For example, if you have ammonia and then 2 moles of ammonia, meaning to say there's 2 moles beside nitrogen. Okay, so 2 moles of ammonia, but you will never say 2 atoms of ammonia. Because atoms is representing individually by breaking each element in the compound. And atom is the number of mole times the subscript talaga siya. So it happens that in a nitrogen, in a compound ammonia, nitrogen has no value for the subscript. So 2 times 1 is just equals to 2. So that is 2 moles of ammonia. Okay, it's not 2 atoms of ammonia. Okay, there's a difference. Okay, but in law of conservation of mass, or specifically the law of conservation of matter, it is the number of atoms to be balanced, not the number of moles. Theory, okay, like that. And the unit or amount of a substance in a chemical reaction is the mole, M-O-L-E, not the atom, and not the molecule, and not the particle, okay, and not the ion. It's always mole, M-O-L-E, represented as small letter n, which is very useful in the ideal gas law and some gases problems in physical chemistry and unit operations and thermodynamics also, especially also in chemistry and a little bit of physics. Okay, so 2 moles of ammonia is equals to times 2 siya, so 4. 4 moles of ammonia is equals to 2 moles, okay, of nitrogen gas, like this gas, okay, okay, 2 moles of nitrogen gas, but this is stated 2 moles of nitrogen gas, but this is also stated 4 atoms of nitrogen, okay, because 2 times 2, okay, both is correct in this situation. So 2 atoms of nitrogen gas, okay, 2 moles of nitrogen gas is equal to 4 atoms of nitrogen. But you will never say 4 atoms of nitrogen gas. Only nitrogen. Because 2 times 2 man siya, it's the totality naman siya. But for moles, you will say nitrogen gas. Okay? But in atoms, nitrogen only. Because in atom, individual man siya. Without considering the subscript. Diba? When you balance the chemical reaction, you have to do the monoatomic element, not considering the subscript. If you can remember that one. Nitrogen, hydrogen, sulfur. They will never put two, even though that is a diatomic atom or diatomic gases or diatomic element. You will never say like that in your balancing equation. You will just put sulfur, nitrogen. That is the reason there. Okay? That is because that is number of atoms. Okay? Like that. Okay? So you should familiarize, if you want to become a chemical engineer, you should familiarize the atom, the molecule, the moles, the particles, the ions, okay, the substances, like that. So each category you should know the definition, the theory, its limitation, and its restriction, one over the other, so that you can really understand. Okay, something like that. So start with a basic foundation of what's really the picture of that terminology all about, so that we can really understand if you apply that in problem solving. Okay, like that. Okay, so 2 moles of nitrogen gas plus 6 moles of hydrogen gas. Okay, muna ni siya guys, because we multiply this by 2 man siya. Okay? So always carry the result of the enthalpy after multiplying that with the number, huh? Okay. And the second reaction also, we have, 3, so 6 moles of H2O, 6 moles of hydrogen gas, plus 3 moles of oxygen gas, like that. Okay. Take note, we have now the same quantity, the 6H2 and the 6H2 at the top and the 6H2 down below. So you need to reverse the second reaction so that we can cancel this H2. Okay? So reverse. Now, apply the addition. So 4 moles of ammonia. In this situation, we need to be extra careful in carrying the number of moles. Okay? 4 moles of ammonia, okay, plus all the reactants first, huh? Be careful. Plus, okay, we reverse this the second reaction. I forgot to reverse, but we should reverse this here na lang siya. Okay, so 3O2. Okay, when you reverse the chemical reaction, you will never reverse the sign, only the enthalpy change. Okay, values. Okay, 6H2 and then 6 moles of H2O. Okay, muna na itong gamiton guys. Ito na mag-reverse siya. Okay, the bottom part, we will use this one, ha? Okay, so we need to 1716 joules in the second reaction. It will become now negative. Okay, negative 1716 enthalpy change of the second reaction now because we reverse that one, right? And then still the same with the first reaction, which is nothing for joules, right? Okay, positive. Okay, like that. So 4 moles of ammonia plus 3 moles of oxygen, plus 6 moles of hydrogen gas, okay, is equals to 2 moles of nitrogen gas plus 6 moles of hydrogen gas plus 6 moles of H2O. So in here guys, it's very obvious and very transparent that we can cancel the 6 moles of hydrogen gas, right? Yes. So what's left here is the 4 moles of ammonia plus 3 moles of oxygen gas is equals to 2 moles of nitrogen gas. Diba? Ang saya-saya special. Plus, if you love, chemistry and, chemical reactions. 2N2 plus 6H2O. So this will be our final overall chemical reaction. But take note, guys, we need to balance our overall reaction. Still, we have to balance. Maybe somewhere along the way we are wrong, right? So, again, 2 individually. Nitrogen, 4 in the left, in the right, 4. Oxygen gas, 6 in the left, okay. Oxygen in the other one is also 6. So therefore, we conclude this is a balanced chemical reaction. This one. So we answer now the overall reaction, what is being asked in the problem. The second question, what is the enthalpy change of the reaction? So we need to have the delta H enthalpy change of the reaction reaction 2 and reaction 1. Okay, which is the final here. Okay, the final here. So we consider the final stage, which is positive 94, okay, and negative 1716. But take note you should multiply every time. Okay, if you multiply with 3, multiply also the enthalpy. Okay, like that. Always, because it will become really wrong, a very big difference. I'll tell you honestly, okay, something like that. So 94 minus 17106 will be equal to how much? Okay. I sorry guys, there are 3 chemical reactions. We are not yet done. Oh my gosh, there's still 3. Oh, no. Chemical reaction number 3, sorry po. Okay, there's still chemical reaction 3. Oh my gosh, too much. Okay. Okay, wait for a while. We have still another chemical reaction. Okay. So after that, okay, after that one, so we have now this one, the chemical reaction, we reverse, and we have now the overall reaction. We still use this one also. Okay. Di ba ningon ko stated a while ago that this is our overall reaction, but still we have to add this N2O2 is equals to in our third chemical reaction, and the enthalpy change is negative 180 joules, something like that. Should be extra careful. Just like me, I'm running out of time because I want to sleep. Oh my gosh. Okay, so investigate all the chemical reactions, even though how many are that. Okay, so I'm also fan of using only 2 chemical reactions, but actually these are 3 chemical reactions. Too lengthy. But I tell you honestly, and board examination, it will not come like this. Usually it's very easy. It's very basic. Adding only 2, reaction 1 and reaction 2, and there's an enthalpy change already, and you have all to do is to not just like this. Remember the rules, like that, balance the chemical equation. But here it's too much. Okay, it's I remember only 2 chemical reactions will be added. Here is 3. Okay, so let's do it, right? Because it's having 3 chemical reactions. Okay. Now we have the third reaction, N2 plus O2 is equal to 2NO. In this situation, okay, what you will observe in this reaction here, there is a nitrogen gas, 2 moles of nitrogen gas in the product side. Okay, in the product side. And then the third chemical reaction here, N2O2 is equals to...
The Bluetooth device is ready to pair.
It's equals to 2NO. So you need to add na lang siya, no need to reverse. Okay, because you can cancel that out when you add. Okay, add. So, N plus N2O2, our chemical reaction number 3, N2O2, okay, is equals to 2NO. Okay, and the enthalpy change for this, guys, will never change because we don't do anything yet. Negative 180 joules. Okay, take note, the number of moles is not balanced. So we need to multiply that third reaction with 2 so that we can cancel that out. Okay, multiply by 2, and that's the time the enthalpy change of reaction 3 will be multiplied by 2 also. Okay? Ganun siya. Okay, you should be patient, okay, in doing this individually. Something like that. Okay? So negative 360 joules na siya. Okay? Ang enthalpy change. Now, this will become 2N2 plus 2 moles of oxygen, or 2NO. So we will use this one. Okay. We have to add, okay, that one inside the rectangular shape. We add that 2. So the procedure again, add all the reactants, then equal to the products. Add all the products. Okay, something like that. Okay? Do not rumble because it will become wrong. Okay? Like that. Okay, let's do it. Last na ni siya. Chemical reaction. Okay, so 4NH3 ammonia. Oh my gosh. 4NH3 ammonia plus 3 moles of oxygen gas is equal to 2 moles of nitrogen gas plus 2 moles of oxygen gas. Right? Multiply naman siya 2. 2 and 2. Okay. 2O2 and 2NO na with siya. So, again, 2N2O2, 2N2, 2O2. Investigate again, ha? Okay, so multiply by 2, so this will become 4NO. See? So you should be patient and review as much as you could. Okay? So 2, okay, so that you will never be wrong. Okay? That's the procedure really how you have to review. Okay, so 4 ammonia plus 3O2 plus 2N2, okay, plus 2O2 is equal to the products, okay, 4NO, and then 2N2 plus 6H2O. So this is now our overall reaction upon adding the reaction number 3, which is the N2 plus O2 is equal to 2 moles of nitrous oxide. So we cancel now the nitrogen gas because it has the same appearance or quantity. Ganon. So what we left now here is 4 ammonia gas plus 5 moles of oxygen gas is equal to, okay, 4 moles of nitrous oxide plus 6 moles of water. So, muna yun din siya, guys. Muna yun din siya. Then, balance the chemical reaction by investigating each element of the compound. Okay. Nitrogen 4, and the other side 4. Hydrogen 12. Hydrogen 12 on the other side. Oxygen 10 on the other side, oxygen 10 in the left. So perfect. Balance the chemical reaction, this one. And this is now the answer of our first required overall reaction. And now, delta H reaction, okay, so we have to add the enthalpies. In the third here, okay, we multiply by 2. So we have now positive 94 joules in the, okay, reaction 1, enthalpy change in 1, or R1, ganun lang ha, and change in enthalpy in reaction 2, and change in enthalpy in the last part, which is 3. Ganun lang siya. Okay. Total change in enthalpy in the reaction is equal to enthalpy change in reaction 1 or R1 plus change in enthalpy in reaction 2 or R2 plus change in enthalpy in the reaction 3, and then substitute values. Oh, ganon. So what is the first? You have 94 joules. Carry the sign very well. Okay? And then 94 joules is in here. Look at that side, 94 joules. Okay? And the second was negative 1,716. Negative plus negative 1,716 joules. And then the last is negative 360. Because it's negative originally man siya. So negative 360 joules. Okay, so add this to 94 joules, positive 94 joules minus negative, minus 1,716 joules minus 360. What is your total enthalpy change of the reaction? Actually, it's just the same. Total heat of the reaction. Okay, total heat of the reaction or total enthalpy change of the reaction. Because enthalpy is also heat content. Okay? The heat is very clear here. It's being transferred. Okay? Because you have to add, you have to rotate, you have to shift, you have to reverse the sign. So it's very, very obvious that the heat transfer was being done from chemical reaction 1, chemical reaction 2, chemical reaction 3. So this is really as an example of a heat transfer through gases. So this is convection. Okay, heat transfer through gases or through, yes, through gases lang siya. Okay, heat transfer through solid substances, it's conduction. And heat transfer through radiation also, we have the last one. And heat transfer through gases is convection. Okay, so like that. But referring most of the times with the molecules. What is being transferred are the energy molecules, which is specifically the heat energy. Okay, that is heat transfer. For the radiation, it's simply the electromagnetic waves are being transferred. Or it could be, what do you call this one? Ultraviolet ray, gamma ray, alpha ray, and beta particle. Something. You should review also the nuclear chemistry. My previous vloggings about that. Beta particle, beta decay, ganun siya. So that is more on heat transfer through radiation, and the best example for that is the radiant heat of the sun is being transferred to plants and animals, including us, because we are also considered as an animal, the highest form of animal or mammalia. So the heat transfer coming from the sun, the radiant heat of the sun is an example of heat transfer through radiation. So there are three: heat transfer or heat transport or heat transmission. Okay? Something like that. So, this is the temperature of reaction is equals to, okay, i-add na lang mo siya. Okay, 94 negative 1982 joules. Oh my God, negative siya. Hala. What does it mean? I obtain a negative enthalpy change of reaction, which is a negative. Hala. It is an exothermic reaction or an endothermic reaction. Because in physical chemistry, we need to discover if it is endothermic or exothermic. Anybody can answer for this? This will come out in the board examination. If the enthalpy is negative, what is the type of environment? Exothermic or endothermic? Guys. If it is a negative heat, what is that? Negative heat. So the heat is being, if the heat is being released from the system, what is that? Okay? It is released from the system. What is that? So this is exothermic reaction. Because it is released from the system. Okay, something negative. Because the enthalpy change of products is less than with a reactant, something like that. Okay, so it has a negative delta H of reaction. Okay, like that. You got the point? Okay. Less than man siya. Okay, the enthalpy change of the product in the formation is less than to the enthalpy change of the reactants in the formation of the chemical reaction. So that is a negative change in the enthalpy reaction. So that is exothermic reaction. Okay, and then the reverse holds true in endothermic. The enthalpy change of reaction is positive value. So meaning to say, the delta H or the delta change of formation of the products is always greater than the enthalpy change of the formation of the reactant. Okay, so that's theory. So I will show you. Okay, if the enthalpy change of the product formation in a chemical reaction, okay, is less than to the heat enthalpy change or enthalpy change of the reactant's formation. Okay, this dan siya ha. So this is a negative equal to negative enthalpy change of the reaction, Rxn. So therefore, exothermic reaction. Okay? Ganun siya. Because sometimes in board examination, it will be asked, what type of reaction? A, exothermic reaction. B, endothermic reaction. C, equilibrium. Ganon-ganon, and D, none of the above. Sometimes E, both A and B. Ganon. Okay, and you have to choose. And if you don't understand the process, then you cannot really get the correct answer of the theory. Okay? So that is exothermic. And then if the enthalpy change of the product is greater than the heat or the enthalpy change of the reactants, so we have a positive delta H of the reaction. So this is endothermic. Okay. Like this. Katawanan kayo ni siya, I will explain ha. Katawanan. Naroon ko katawanan. Okay, because this is endothermic, right? Okay. So meaning to say, if we say endothermic in chemistry, manggod guys, reverse. If endothermic, the environment is cold. Right? If the environment really is cold, so meaning to say, the heat is being given off away from the environment. And then why this is positive heat and this is endothermic? Supposedly this is exothermic because positive heat meaning the environment is hot. Why it is endothermic? Meaning this is from the system ng siya. Okay, from. Always consider system, surrounding. The surrounding is the environment, ha? Okay? Like that. And then system and surrounding. You can either use surrounding and environment interchangeably if you want. But most of the time, they use the surrounding. Sometimes, but in the problem solving, they will use the environment instead of surrounding. They will mention surrounding really. That makes difficult sometimes in the problem. Okay, because we interchange the word. Okay, because in second law of thermodynamics also, it states that the entropy of the universe is equal to the entropy of the system plus the entropy change of the surrounding. It's not saying the entropy of the environment. But actually, environment and surrounding there is referring to be the same. Okay? Like that. For example, me, I'm sitting here. My system is the me and the chair. This is the system I consider. And the surrounding is the room. Room. Now, if I will release my heat, the room will receive my heat. So, me here will release my heat there to the room. So the surrounding or my room is exothermic because they receive the heat. Okay, and me in the system is endothermic because I released my heat. So this is what we mean by the reaction here. So meaning to say I am the reaction here, the chemical reaction here. Okay, something. So system ang gibasihan niani sa physical chemistry. In physical chemistry and thermodynamics, exothermic and endothermic identification will be based in the system, not on the surrounding. But in chemistry discussion, chemistry, it's the reverse. It's always basing on the surrounding. When can we say exothermic and endothermic? For example, it is an exothermic environment, meaning it's very hot. Because the environment is absorbing the heat. Okay? From the system. Ganun siya. So, sometimes it's really confused. That's why you need to dig it up. What's really it's all about? And we need to know the reference point. Okay, reference point. Meaning to say, this exothermic and endothermic reaction are state function. State function is siya. Because it refers on the first reference point, second reference point, like that, initial reference point, and the final reference point, initial stage, final stage, okay, like that. Point 1, point 2, input, output. So state ang tawagan na niya guys sa science, state function. Because it refers to that. Okay? Just like that. Just like in physics, equivalent to vector quantity. magnitude plus the direction. It's gonna be like that. That's why we're gonna consider the sign, whether it is positive or negative. Positive work, negative work, like this. Okay? Ganun siya. So, it's gonna be like that. Okay? Charot. Okay, thank you so much for listening for this. Oh my gosh. For this live stream. I hope you like this, guys. And if you can share this to anybody else, you can share. And then you can comment down below in the comment section also. And if you are not subscribing yet my YouTube channel, you can subscribe. And then you can click the notification bell for some news updates. I'm seeing your channel. Bye bye, everybody. See you later.